Lecture 16, Lie derivative in local coordinates. xi belongs to the manifold M. Don't forget, xi is a label that lives in the manifold, but xi is generated by a real line, see, which the parameter, for instance, is t or lambda. Don't forget that. Now, the Lie derivative Lxy is xy minus yx. This is a Lie bracket, the same as a Lie bracket, where x can be expressed in components. Xi, partial xi, yj, partial of xj. This here they live in the vector space. Okay? Xi and yj are the contravariant components. And the bases are partial respect to xi, partial derivative respect to xj. Now let f be a function, a scalar, and this is a Lie derivative of x or y applied to f. You see, that's applied to f. I substitute here f, and xy act on f minus yx act on f. That's a Lie bracket, okay, acting on f. That's relation 1. Now let's compute separately xy of f. You see, xi, the components, xi partial dxi, apply to, in this case, okay, yj, partial of f respect to xj. You see, just apply xy at f. I have to repeat, okay, x and y expressed in terms of components. So this here, I can apply the chain rule, the Leibniz rule. You see, there are two terms over here, and attention from this second derivative of f, xi, xj. Now this is relation 2. Similarly, okay, yx act on f, yj partial xj. This is the vector x, okay. Then I apply the product rule or Leibniz rule. You see, I expand this, and this is also the second derivative. That's relation 3. Then I substitute, okay, this relation 2 and 3 into relation 1. Okay, it's clear. Okay. Now, when I substitute, this will be plus sign, this will be minus sign. You see, assuming that f is a smooth function, I can cancel, you see, the blue one. So this leads to these two terms over here. Okay, also applied to f. So this is a Lie bracket xy applied to f. So this is expressed, the Lie bracket, okay, in terms of the components. It's just this here. Now, this now I will apply to a particular case on a scalar f. There is no y here, you see? It's Lx applied, the Lie derivative applied to the scalar f. So it follows from here, where I don't use capital Y, this is x applied to f. But the vector x, in terms of components, okay, it's xi partial dxi. That's a blue one, you see, applied to f. So it's xi partial f respect to xi. Now, this relation will be used to obtain the Lie derivative of the covariant component of one form. The covariant component is omega sub I. This will be derived in the next lecture 17. You see, that's clear, okay, what is written, okay, on this lecture 16.